Chapter 5, Lesson 4 on solving compound inequalities. So a compound inequality is two inequalities that are written together and work together. And so we can't just solve one of them, we have to kind of solve both of them and see how they work together. There's two types of inequalities. So I'm going to go through one type and fill it in on this page, and then the next type on the next page. So the first type of inequality that we're going to look at is what we're going to call the AND type of inequality. The AND type. And is what it looks like is sometimes it actually says the word AND. For example, it might say negative 2 is less than or equal to x minus 3, and x minus 3 is less than 4. It might actually say that word and, but it might also not say the word and it just looks like this. Negative 2 is less than or equal to x minus 3, which is less than 4. So even if it doesn't say the word and, if it's all written in one compound inequality together with no words, we can assume that it is an and. Okay? The words to describe that type of graph that we're going to see is an intersection. And so what we're going to do is we're going to solve both of them, and we're going to graph both of them, and we're going to see where they intersect or where they cross or where they are the same. That intersection of the two graphs. So an example, we'll just do a simple example, is let's say x is less than 5 and x is greater than or equal to negative 8. So if I graph x is less than 5, I have 5 and open circle, and x is anything that's over here. If I have x is greater than or equal to negative 8, I have negative 8, a closed circle, and everything over here to the right. But now is what I have to do is I have to think about what if those two are in the same number line. So now I want to kind of combine them, and I want to say, okay, so here's the number line. Here's negative 8, here's 5. So x can be anything that is less than 5, so kind of an open circle here going this way, or greater than or equal to negative 8. Well, where those two graphs cross are right in here. And as how they cross is that it cannot touch 5, because that's not true on both graphs. It can touch negative 8, and it's going to be this intersection that's between them. So when I'm looking for this solution, I'm going to circle it in blue. This graph right here is my solution, the one that shows the intersection between negative 8 and 5 and what is true. Now make sure that your circles are colored correctly as well. Okay, the other type of graph, the other type of compound inequality is what we call our OR inequalities. And what those look like is it might say x is greater than 2, or x is less than or equal to negative 1. So it has to says or. It can't just be written without a word. If so, it's an and graph. This is an or graph. And as how we describe the or graph is by a union. Okay? And as what a union means is that we just put them together. We don't have to see where they're the same, because they might not ever be the same. But it's or, so it can be this or this. It doesn't have to be both. So an example, let's go ahead and graph the one up above. X is greater than 2, or x is less than or equal to negative 1. So I'm going to show you how to do it with graphs that are on top of each other. So x is greater than, here's 2, and it's greater, open circle, arrow to the right, and then I'm going to put a graph right below it. X is less than or equal to negative 1. So I'm going to go ahead and put 2 on that graph, and then here's negative 1, a closed circle, and an arrow to the left. And an OR graph, all I'm going to do is combine the two. And so they don't have anything that's in common, That's okay. So my solution is, here's -1, and here's 2. It can be anything including -1 and to the left, or anything not including 2 and to the right. So the only things that it cannot be are any of those numbers that are right here between -1 and 2. Now it can be -1, but it cannot be 2, and it cannot be anything between them. But it can be anything that is on those lines. Okay, so let's look at an example of an and inequality. So this one doesn't say the word and. This is the one I used before as an example, but now is what we have to do is we have to write it. We have to say -2 is less than or equal to x minus 3, and x minus 3 is less than 4, because now I need to solve it. So I'm going to do +3 plus 3. 1 is less than or equal to x, +3 plus 3, x is less than 7. And remember, this is an and, so we're looking for the intersection. So I'm going to graph these two on top of each other. So I'm going to say, okay, here's 1, and I know I'm going to need to include a 7 on this graph below it. And then on the one below, I'm going to need to include a 1 and a 7. So I'm going to first graph my first inequality. 1 is less than or equal to x. Now if I need to rewrite that, that's x is greater than or equal to 1. So closed circle and an arrow to the right. And then I'm going to graph my other one. X is less than 7. So an open circle and an arrow to the left. And then I look for where do they intersect. And so I see that they're intersecting all in here. So I'm going to then make that on one graph. Closed circle on 1, open circle on 7, and it is the intersection where they are the same, and they're the same between 1 and 7. All right, let's do one more example. Now this one actually says the word and, so I know I'm looking for that intersection. So I'm going to do +3 plus 3, y is greater than or equal to -8, +3 plus 3, y is less than or equal to -5. So now I'm going to make my two graphs, or actually 3 graphs. And I know that they both need to include -5, -8, -8, -5, -5, -8. And we want to make them all similar so that we can compare them. So the first one, y is greater than or equal to -8, closed circle, and an arrow to the right. And then the other one, y is less than or equal to -5. So less than or equal to -5, and it goes all the way this way. And then where are they? So this one must stop here, and then it must stop here, and they are both closed circles. And their intersection is going to be this part right in here. All right, last example. This is an or example. So we know it may not cross each other. It might, but it doesn't have to. So we're going to solve both of them. -1 minus 1, a is less than 3. +1 plus 1, a is greater than or equal to 4. So I'm going to make 3 graphs. And they're both going to include 3 and 4. 3, 4, 3, 4. And my first one, I'm going to graph a is less than 3. And then the next one, I'm going to graph a is greater than or equal to 4. And then I'm going to say, okay, now I'm just going to put those together. Open to the left and closed at 4 and to the right. So the only things that that cannot be true here is 3 or 3.2, 3.9, anything between 3 and 4.